do the SOL, and then start our notes for today. So on the chart guide, which numbers do we want to see, do go over, have questions about? A lot of 3s and 4s, some 2s. 2 can be done on Desmos. I forgot about a way to check yourself with 4 on Desmos, so I'll show you that, and then we'll do 3. And 5 can be done on Desmos, so we'll do that one. So let's start with that. So I have stuff up here already, because I was playing around with it. So for number 2, if I put in everything, it says f of -4, so that's your x value. Be careful because there's a negative outside of the x cubed, and your x value is negative. So you need 2 negatives there. And your answer should have been 16. So you would write that f of -4 equals 16, or f of x equals 16. Remember, if you're using this answer, to say that it was done on Desmos. Questions on that one? Number 2, you're looking for the range. Imagine that this has endpoints. Because we've now talked about interval notation, I'm going to write this 2 different ways. Range, lowest to highest, would be at -2 going to 5. So you can write it in set builder notation as we've been doing throughout the year. So y such that it's going to be between 2 numbers. So -2 less than or equal to y less than or equal to 5. Or when we were talking about inequalities and doing interval notation, these are both endpoints, closed endpoints, so that would be a square bracket, -2, square bracket 5. In fact, 5 square bracket. So either or. Questions on that one? Four, you would have to do algebraically, but then you could check yourself in Desmos. So distribute everything. 8x minus 12 minus 6x minus 12 plus 3x minus 12. A lot of 12s in there. And then combine all of your like terms. So 8x minus 6x gives us 2x. 2x plus 3x gives us 5x. And then we had, these were all minus 12s. So that would be minus 36. So if we were to put this into Desmos, and you have to capitalize all the x's because it won't let you put in just x, and then add in a slider, change the value, and then put in your final answer, it should match. So that would be a good way to check yourself. But make sure it's capitalized, otherwise it won't work. And then 5, if I plot the 2 points that were given, now you could do this algebraically, but in Desmos, if you plot the 2 points that were given, it gives you your y-intercept, so you just have to find your slope, which would be -1/2. So the equation would be y equals -1/2 x plus 3. questions on that one? Yes, 5x minus 6. Alright, we're going to go through the answers on the SOL sheet, and then we'll talk about how to do those in Desmos. So all of these questions could have been done in Desmos. You could have used Desmos to help you solve them. For 7, I did solve these by dividing everything by 4 for the first one and dividing everything by 3 for the second one. I didn't show that, but I can show it. And then they would both be solid lines, both shaded above, and the overlapping would be this area right here. You could pick any 2 points for part A that are in the solution set. They could be points that were in the part B or random ones. Up to you. Three, 7, 1. So if you want to pick different ones, that's fine as long as it falls in the shaded area. Then for part B, you would define points that were also in the solution set. None of these work. -4, 4 was definitely in there. I don't remember which one that was. -4, 2, I just double checked because it fell on the line, but that still worked. When I checked it algebraically, it worked for both. Let's see. 4, 4 did not work. And I didn't need to check that one because it's obviously not in the shaded, overlapping shaded area. So there were only 2 for that one. Questions on 7? Anyone still writing any of this down? If you want this work, you can write it, but again, not a necessity for at least the second one. The first one, you may have had to check algebraically. Let's see how many times we have to do this. For number 8, they were already solved, and you just have to find which of these ordered pairs or solutions. So if you graph those in Desmos, it will show you, and you can start putting in these ordered pairs. These were the only ones that worked. 1, 1, 3, -1, 4, 3, 6, 0. Some of them fell on the lines, and even though they were both solid lines, I still double checked. I think this one was the only one that fell on the line. 9, you could have solved these 2 equations to get them in slope-intercept form, but if you were using Desmos, you did not need to do that. You could have just graphed them both. These, not all of them. These 2, I think. Sorry, this one and this one fell on the line, or were like really close or something, so I double check those 2 again. Yeah, make it pass. But those 3 were the only ones that worked. And then 10, same thing. You could graph those both in Desmos. There was only one that fell in the overlapping shaded area, and that was B. Yes, Desmos.
It has to be the overlapping.
Yes. For the systems. When it's just one, it just has to be in the shaded area. Let me know when that goes through. So then I'll show you the ones on Desmos, and I'll tell you the next set that you'll need to do. question. I put in the two original equations. I didn't change them or solve them. There we go. It's really messy. I put in all of the order pairs. The labeling is not really necessary. But we can see negative 4, 4 definitely works. Negative 4, 2 fell on the line in the shaded area, so I just want to double check that, but nothing else worked. For 8, put in the two equations, put in all the order pairs. The ones that fell in the shaded area for certain, 6, 0, 4, 3, 3, negative 1. 1, 1 fell on the line, so did 0, negative 4, but this one wasn't in the shaded area, so that one didn't count. And 1, 3 wasn't in the overlapping, so that one also didn't count. Did not solve these two, just put them in, put in all the ordered pairs. The ones in the overlapping is kind of hard to see because of the colors, but 0.5, negative 2 definitely worked. 0.04 was on the line, so I double checked that one. 0.75 was outside, and 0, negative 5 was on the line, so I double checked that, and negative 1, negative 6. And then the last one, you may have to readjust because some of the numbers are bigger, but then the only one that was in the overlapping was 4. Okay. Questions on any of those? So then next Thursday, 6A and 6B are due. Of the things remaining in this, we only have one objective that we have not talked about lesson-wise, but everything else you should be able to do. Make sure you are practicing that, especially with your SOL coming up. Go back, review things we've already covered. Look back at how do I do this in Desmos. That way you are prepared for when the time comes. We'll also be doing more SOL review as the time comes. And then everyone should have these notes in front of them. As I mentioned on Wednesday, today we're starting our new unit of lessons, factoring. The little pink book I gave you is for your own practice so that you can go through different factoring things and practice. We're going to do some review on previous stuff before we start this. So for these warm-up questions, you would solve this or simplify it by distributing. But when we start to distribute, we end up multiplying like bases together. Remember that if you don't see an exponent, it has an exponent of 1. And you're adding the exponents together. So what would this become? When we multiply a and 3a. A squared. And then the second part would stay the same. So when I multiply negative 2m to everything, what would this first term be? Yes. The m would be cubed, but it would be negative 2 in front. What would the second term be?
Plus 6.
It would be m to the second power, but we're multiplying it by negative 2 also.
Oh, so.
And then the last one would be a normal plus 2m. Then in the third one, it's a little bit more challenging because there's more variables, so be careful. only the same basis exponents get changed. So the x in the first one, the y in the second one. So what would this be when I multiply it?
4x to the 1 and negative 8y.
So the variables that were already there still have to stay there. We can't make them disappear. So 4x to the 5th y minus 8x to the 3rd, and then y squared.
So we have to add them to both.
So we can't get rid of the x just because this one doesn't have one. We're still multiplying it to it, yes. Right? So that was a quick review on multiplying exponents together. I'm going to give you this to fill out. So we were just distributing. Now we're basically undoing that, and that's called factoring, where we separate a polynomial back into a product. So we're going to be given a lot of what looks like the simplest form and have to factor out or divide out what they have in common to get it back to a factor form. So we touched on this when we were doing literal equations a bit with some of the Khan Academy questions, with some of the examples. And I just said it was like undistributing. It's basically that, but the name, the term for it is factoring. As we are starting this process, polynomials that can be factored are called primes. So you may remember prime from when we were doing radicals, and the only numbers that could be multiplied were one in itself. Prime has a lot of different definitions. So I'm going to work out this example, and then we will start the actuals. So as we're looking through this, and I'm going to show this as well, we're trying to find what these have in common, what we can divide out in common. You may know what that is already. You may want to list out like a small factor tree or something off to the side, whichever helps you better. I am going to list them out to the side. So for 4, I'll just talk about the numbers first. What are the factors of 4? 4 and, okay, what times what will give us 4? 1 and 4 and 2. There we go. And then for 8, 4 and 2 and 1 and 8. So for all of these, you'll have to remember the 1 and whatever also, because that could work. Sometimes, but not all the time, whatever this first number is, they know what you're going to divide it. It depends. So. Then you're looking for, of the factors, what is the highest these have in common? 2 highest? 4 is the highest of both. Which is why they have this 4 out here. So what they did was divide both of these by 4. But when they're dividing, they don't really want to get rid of it. They just want to say, this is what I was dividing by. So they put it on the outside. And then as they're dividing, they're saying what's left, and they put that on the inside. So this would be 1, this would be 2. Where the numbers come from. Then your variable piece, you're looking at the lowest amount of A's these both have. Well, the highest amount of A's they both have, but you're looking at that lowest exponent. Because this one doesn't have 2, but they both have at least 1. So I could take an A out of both, which is why there's an A out here. And then you're subtracting your exponents. This would leave us with 1, this would leave us with 9. Our goal, after we divide out whatever's common, is to make sure that inside is prime, that nothing else can be divided out of it. They don't have anything else in common. Okay, so we're going to do some examples, but do we have any questions so far? process we're doing is factoring out the greatest common factor, your GCF, so keep that in mind. When I say those letters, that's what that means. So let's start with number 1. If you want to list out the factors, you are more than welcome to off to the side. You do not need to do that, but if you don't know your factors, you may need to do that. What is the highest number we can, well, let's list out the factors for this one. I won't do this for every single one. Factors of 3, 3 and 1. Factors of 12, 1 and 12. 3 and 4. What's the highest these share? 3. So that means we're going to divide both of these by 3, but not really divide because we still need that, so that number goes out in front. They don't have x's in common, because only one has an x, so we wouldn't be dividing out an x. So then what would be left on the inside? X plus 4. And that would be your answer. If you wanted to check yourself, you could distribute it back. And as long as this matches the original, you know you did the right thing. The checking part is not necessary, but it does help. Questions on that? Let's try 2. Highest number we can divide out of both. 7. And it's nice because they're both the same. Can we divide out any variables? Do they have variables in common? No. This dividing piece you don't have to show, but if it helps you see what's happening, you can definitely keep doing that. If we divide out 7 to both, what's left? 1. Y minus 1. I'm going to list out the factors for 3 because there are a lot for 36. So 8, we found the factors before, 1 and 8, 2 and 4. For 36, give me all the factors of 36. 6, 9, 36, 12 and 3, 3 and 12, so you have what is the highest that we share? 2 the highest? What is it? 4. Do they have any variables in common? No. If they both had m or both had n, then that would be different. So we're dividing both by 4. What would be left? And there's nothing else we can divide out of that. So this is when that method I said before doesn't work. 8 is not the highest that you can divide out of both, so you have to think smaller. Sometimes it's the first number, sometimes it's not. Okay. 4. What is the highest number we can divide out of both? 5. Can't divide out any variables because they're not the same. What would be left? X plus 1. Right, now we're going to get on to some more challenging ones. So let's do 6. Highest number we can divide out of both? For 6. 4. Do they have any variables in common? Yes. And then how many y's can we take out of both? Just 1. So 4y is what we're dividing. What would be left? for the second one. What about the first one?
1.
It's y minus 6, and that would be it. And you could distribute that back, and we should get 4y squared minus 24y. I know we're moving at a fast pace. Do you have any questions so far before we keep going? Let's do 7. Highest number we can divide out of both? 3. Do they have any variables in common? Which variable? D. If we take out 3d, what would be left? Let's move on to 9. Highest number we can divide out of both? 15. Now, I'm going to show you what happens if you don't choose the highest number. 15 is the answer, but let's say we forgot about 15 and we said 5 instead. I'm going to just write a side note, it is 15, but let's say we did 5 instead. Do they have variables in common? Yes, which ones and how many of each? A and B, how many A's, how many B's? 1 of each. So if I divided 5AB from both, what would be left? So if you look on the inside, could we divide something else out of those two? Yes. That's how you know you probably didn't pick the highest number. So we could divide these both by 3. So that 3 you would bring out and multiply to the original and change the inside. So always double check, can I divide anything else out of the inside? If you can, you didn't pick the highest number, which is fine as long as you get the highest number eventually. Questions on that? If you were taking it out in general, it would be on the outside, and anything on out here gets multiplied. Let's do, now we have some without numbers. Let's do 12. Don't have a number in common, or the highest number, the GCF is 1. Do they have variables in common? And then how many of each? 1 of each. So if I'm dividing out xy from both, what's left? X. So don't let the just variables confuse you. It works the exact same way. Does 13 have something in common? Sometimes you'll get answers like this where you can't divide out anything. They don't have variables, they don't have numbers. This would be fine. Alright. Like you could divide out a 1, but that wouldn't change anything, so you wouldn't do that. Some more complex ones. Let's do 14. So you may have to think about the factors of 48, think about the factors of 18. What's the highest number we can divide out of both? It is 6. And then, of the variables they have, which ones do they have in common, and how many can we take out of each? 1a, 1b, just 1c, 2 c, so c squared. We're dividing 6abc squared, Jasmine. Look at the lowest amount of exponents. Because I can't take 2 out of 1, I wouldn't have anything left. But I can take 1 out of 2, so always look for the lower one. So if we're dividing, what would be left? 3a, the b's would cancel, the c's would also cancel, minus 8. What was the rest of that? So there's this one. Questions on that? Let's do one with 3, number 16. So now you're thinking of the greatest common factor of all 3 numbers, 9 and 18 and 24. Say it again. It is 3. And then do they have any variables in common? And how many? R and how many R's? Right, just 1. Because this one in the third term only has 1. So sometimes you'll have a bunch of exponents, but only be able to take one thing out of everything. We divide out 3R to everything. What's left? 6. Keep going. And this could be, anyone can chime in. RS minus. Yep, 8.
8 S.
So it's weird because it still has like a lot of numbers and exponents, so you think it can be simplified more or divided out more. But these 2 are the only one with R's. These 2 are the only one with S's. These 2 can be divided by 3. These 2 can be divided by 2. So there's nothing in common. Regina? Do all of them have S's in the original one? No, that's not. So they all have to have the variable in order for it to work. Okay. More complex. Number 18. Basically, if you can do these complex ones, you can do any UCF factoring things. Think about the common factors. Yes, 6. What variables and how many can you divide out of everything? A squared, yes, and B squared, yes. So if we are dividing that out of every single thing, take your time, do it slowly. What would we have left?
2.
So what would this be if we divided this? 1. Again, it looks like we should be able to take something out, but we can't. There's only 2 A's, there's only 1 B, 2 numbers that can be divided by 2. Any questions so far? Let's do 24 and then any other questions you have, and then we'll do something else. We'll go through each one. What's the highest number we can divide out of each? 3. Look at your variables, look very closely, look for the lowest exponent of each variable. 1A, 1B, 1C. 1A. It's 2 B's and 1 C, yeah. again, take your time, divide it, look for each one, subtract your exponents, be careful. What would be left?
3 minus 3a.
One thing, yep, see?
B squared is C squared.
It's a lot. Okay. No, you can put B1 if you want. If that helps you, go for it. Do that. All right. Do we have any questions on how to factor out the GCF? All right. Are there any that we skipped over that we want to do before we switch gears? Before we switch gears, I do want to say one thing. So as you're practicing in Desmos, this would be really helpful for you. In Desmos, there's a feature to help you find GCFs faster. So while you need to know them for the test we take for SOL, this is good to know. So in your keyboard, in your functions, if you scroll all the way down to number theory, there's GCD, which is greatest common divisor, same thing as greatest common factor. You can put in however many numbers you need, so I'm going to make up some. Put commas in between them, and it'll tell you what the GCF is. So that only helps you with numbers-wise. It doesn't help you with variables-wise, so you still have to look at your variables and be able to tell that. Okay, questions on that? On the next page of your notes is the next piece of factoring we're going to talk about. Because GCF is just really one part. There are multiple, as you'll see in the next week. Okay, so warm up, let's do a couple of these. We don't need to do all three. Way back when we talked about multiplying binomials together and using FOIL or the box method, that's what we're going to do here. To multiply the first terms together, what would that give us? X squared. Multiply the outer terms together, x times negative 4, what would that give us? Negative 4x. Multiply the inside terms together, what would that give us? Positive 4x. And then multiply the last terms together, 4 and negative 4. And then we could combine our like terms. There are only two, the middle two. What happened to those two? They do cancel. So as they cancel, we'll get something that's called a difference of squares. And just like the last piece, when we were factoring, we were undoing the distribution. So we're going to be given something like this and have to go back to this. So let's do one more of these and then we'll do some actual factoring. Right, so if we multiply, we'll do the third one. 2a times 2a, what would that give us? 4a squared. 2a times negative 3b. Negative 6ab. 3b times 2a. 3b or 6ba. That order does not matter because you're still going to combine them at the end. And then 3b times negative 3. Negative 9b squared. Okay. Same thing, the middle cancels, so we have 4a squared minus 9b squared. So that kind of shows you the different types of problems we're going to be dealing with. Okay. So the steps to factoring difference of squares, where you might hear me say dose, difference of squares. Make sure you actually have difference of squares, that there's a minus in between them, that the numbers are perfect squares, 4, 9, 16, 25, 36, 49, 64, all of those things. Or the variables are perfect square terms, something that is even. Then you're going to use the following rule. You're going to have two sets of factors in parentheses. And this is a general case, but we'll use this one too. You're thinking about what times what will give us a squared. A times a. So you would put that first in both. What times what would give us b squared? Ignore the negative for a second. B. So put that second in both. And then you're going to put a plus and a minus in one or the other. Does not matter which one you put first. And that's going to be the rule for every single one. And then if you want to check yourself, you could distribute it back out. Okay, so let's do some examples. So for number 1, we're going to have two factors. What times what will give us a squared? A times a, so a is first in both. What times what will give us 4? 2. And then put a plus and a minus. And that's it. And if we were to distribute it back out, I'll do this for this one, but not for the others. A times a would be a squared, a times negative 2, negative 2a, 2 times a, positive 2a, 2 times negative 4, negative 4.
Do we have to?
No. Okay, let's try another one, then we'll do some different ones. What times what will give us n squared? N. What times what will give us 64? 8 plus x. Sometimes you'll get some that you need to keep the order the same. So what times what will give us 81? 99. And then what will give us x squared? X and x. So whatever the order of the original is, you need to keep your factors the same. Now I want you to tell me, what would your two factors for this one be? C minus 10 and C plus 10. For number 5, that is not a difference of squares, it's a addition of squares. So this would be prime, it cannot be solved. So be on the lookout for those. Because of the plus, it's not a difference. There will be some of those that try to trick you, so please be careful. Okay. Look at this one. Same as these, it just has more to it. So what times what will give us 1? 1. What times what will give us 49? 7. And then what times what will give us y squared? 1. So you just add on more to it depending on what the term is. Questions so far? So then what would the two factors of 7 be? and 10 and 3b and 10. So 3b plus 10, 3b minus 10. So when I ask for the factors, make sure you're saying that. 3b plus 10, 3b minus 10, because that's your actual factors. Let's try 10. What would your two factors of this be?
6 minus 9.
And then the opposite. And 12. What would the two factors of that be?
8.
And the opposite. One of those is just easier. There we go. Okay. Question so far? Flip over to the back. Now some of these are more complex because they either have more variables or the exponent changes. It works the same. But if you have an even exponent, you're just going to cut it in half. So what would 13 be? xy plus 1 and xy minus 1. Let's see if we can do 14. Cut 4 in half. So what would the two factors be? Yes, the n would be n squared. And 9n squared plus 1. Now, before we continue, I'm going to do a side note here. Sometimes you'll get something that you need to factor twice. If I had, trying to think of something good. Whatever this was, let's say you ended up with something here that maybe this was also a perfect square. So I got 9n squared minus 25 as an answer in one of my two factors. I would need to break this down again. So then you would end up with 3 or 4 factors instead of just 2. Of course, this is not the answer to this one. I'm just making this up. But be on the lookout for that, because that could also happen. 17, same thing. Split the variable exponent in half. What would the two factors be? 4. And then last one of this section that we'll do is 19. What would those two factors be? Plus or minus. So we talked about GCF, we talked about difference of squares. There's times where you'll have a mixture of both, where you'll always have to look for a GCF first, and then possibly still do difference of squares. So for 21, what do those have in common? 2. So I would divide 2 to both of these, leaving what? Basically. What would be left on that inside if we're dividing both by 2? N squared minus 36. And then you'll have to ask yourself, can I do anything else with this? Can I factor out something that they have in common? That answer is no, but can I do difference of squares? And that answer is yes. So then what would those two factors be? And minus 6 and n plus 6. The 2 you divided out has to get brought down all the way through. So do not lose that because then it changes the answer. Questions on that? We'll do a couple more of these and then you'll have time to practice. Let's do 24. So highest number we can divide out of both. And then, can we take out any variables? Yes. 1q. So if I'm dividing both of these by 5q, what would be left? Then, can we do difference of squares on this inside piece? They're both perfect squares. All of them are perfect squares. Let's try 27. You may have to list out the factors for that because they're big numbers. So what is the highest number we can divide out of 80 and 125? I think 5 might actually be the highest. If not, we'll be able to see that. How many n's can we take out of both? N squared. So then what would be left? Dividing 5n squared from both of these, what would be left? Minus. Can we use difference of squares? Yes. What would those two factors be? Questions do we have on factoring difference of squares or factoring difference of squares with the GCF? Are there any that we skipped over that we want to see, go back to, have questions on? If not, you can use the remaining class time to work on Khan Academy that's due today, Khan Academy that's due next week for inequalities and factoring stuff. Or work on SOL A.5d. Huh? Yeah. Oh, I'm sorry. There was one more quick thing, sorry. I gotta do this. Write this down on a blank space and then you'll have time to work, I promise. So write both of them down somewhere where you have blank space. You may not have a bunch, but maybe in the side panels, like this. 1/9 n squared minus 1/25. 4/25 x squared minus 9/100. Right now. So sometimes you'll get complicated problems like this, but the process is the same. And as you're thinking about this, your fraction will have two perfect squares. It could be the same, could be different. So what times what will give us 1? What times what will give us 3? I'm sorry, 9, 3. What times what will give us n squared? So that would be 1/3 n for both. And then we figured out the 1 already. And what times what will give us 25? So it looks complex, but if you know how to work it, it's really the same. There's just more process to it. So tell me what these two factors will be. And 2/5 x plus 3/5. So as long as you can do that, you can do the most complicated difference of squares possible. Alright, now we are done. Use this time wisely. Let me know if you have any questions.